All right, you guys, so we're going to be starting chapter 10 here, which is talking about square root functions. So that square root is just the radical symbol there. And we're actually going to be graphing them and just looking at the characteristics of all these graphs. So this is 10.1. You should have gotten this in the mail. If you did not, or if you did not pick it up, please shoot me an email and I can send you over an electronic copy. So let's start here with the fill in the blank. So we're going to start with a square root function. And again, the square root symbol is this, that radical symbol, is a function that contains a square root with the independent variable in the radicand. So we talked about the radicand before, but it's just the number that is underneath the square root symbol. The most basic square root function, I'm going to write it under this line just so you can see a little bit better, is y equals the square root of x. And that's what we call the parent function. All right, so we'll just call this, just like all those other functions that we've talked about, they have that general parent function. And this is what it looks like. So you see the shape, right? If you remember back, the shape of like a quadratic function is that parabola. The shape of an exponential function, it increases rapidly. The shape of a linear function, right? Just a straight line. And then this is the shape of a square root function. And it does stop right here. That's an important part, and we'll talk about why. The value of the radicand, the square root, and this is why, so sorry, this is why it stops right here. So the value of the radicand and the square root function, it cannot be a negative number. So you cannot go into the negatives because we already talked about how you cannot take the square root of a negative number. So that's kind of the basics, what it looks like, and just talking about why that radicand cannot be negative. So the first thing we're going to start with is, instead of graphing, we're going to just start with finding a domain. So the domain is those x values, right? So we're looking at what x values are included within this square root function. So I'm going to go up here now to an example 1. Sorry about the shadow. I don't have a perfect setup here, but I'll do my best. So we're going to find the domain of this square root function. And again, this is a square root function because that x value is underneath the square root, that radical symbol. So to find it, we know that it can't be negative. So we're just going to take what's underneath the square root function, what's underneath that radical symbol, which is x minus 5. We're going to take that, and we just know that it has to be greater than or equal to 0 because we said that it cannot be negative. That's what we set up here. So to solve this, we just get x by itself. So we're going to start by adding 5. It's just like solving these inequalities. Add 5 to each side. We know that these will cancel each other out, and we just be left with x is greater than or equal to 5. And that's the domain. That's all the values that are included within this square root function. So all my x values are going to be the ones that are greater than or equal to that positive 5. So you can stop the video here. You can try this on your own real fast. I'm going to do that on your own in just a second, but I would encourage you to stop the video, try that on your own, and then check your work by pressing play and seeing how I do it. So for this one, for number 1 on your own, I would see that x is the only thing underneath that radical symbol, the square root symbol. So I'm just going to set x greater than or equal to 0, and that right there is my domain. Right, so the domain is all these numbers that are greater than or equal to 0. If I go to number 2, again, look at this plus 7. The plus 7 is not underneath this radical symbol, so the only thing that's underneath the radical symbol is the x. So I'd take x, set it greater than or equal to 0, because I know it cannot be a negative number, and it's that easy, right? That one is the domain, is x is greater than or equal to 0. It's all the real numbers that are greater than or equal to 0. For this last one, looks a little different, right? There we have negative x plus 1 is all underneath this square root symbol. So I'm going to take negative x plus 1, and I'm setting it again greater than or equal to 0. And then I just have to solve this. To solve this, I need to get x all by itself on this left side. So I'm going to subtract 1 from each side. And I would get negative x is greater than or equal to negative 1. 0 minus 1 is negative 1. And then again, there's that invisible math there. -1 is in front of that x, so I can divide each side by -1. And I would end up with my domain of, be careful here, when you divide or multiply by a negative value, this inequality switches on us, right? So it'd be, instead of greater than, it'd be less than or equal to, and then it'd be -1 divided by -1 is 1, right? So a big thing to remember here is when we're solving inequalities, at the end, if you divide, or any point if you divide or multiply by a negative number, this flips, right? So there's my domain, is all the real numbers that are less than or equal to 1. If you have any questions about this, please email me. I mean, you can comment in this video. I don't know, I can't promise you if I'm gonna check that or not, but I can promise you that I will check my email. So let's go to the next page. This is where we graph. So this is example 2. And we are going to compare it back to the parent function, just like we always compare, right? It's really good to know the differences between the parent function and really what this +3 is doing here. Because we know the parent function would come out of the origin here and create that square root function shape, right? Where it kind of tapers off. But let's see what this +3 does. That's on the outside of the radical symbol. So the first thing you need to do is you make a table of values. So we always do that. And for our x values, we get to decide what x values we use. This is going to be important, so it helps us get whole numbers here, is you're going to look at the domain and see what domain values are included. So I know that I would take what's the underneath that radical symbol, which is x, and I would just set that greater than or equal to 0. That's my domain value, so this is the number I'm going to start at, right? Whatever is your lowest value right here, 0, right? If I were to go back to the other ones, it would have been like 1, or that beginning example 1, it would have been 5, but for this one, it's x is greater than or equal to 0, so that's the one I start with. And now, instead of going up by ones, I'm going to have you go up by numbers that are perfect squares. Right, so I'm going to go up by, I know 1, I can take the square root of 1 and get 1 back. I know then my next one would be 4. I know my next one would then be 9, right? And I mean, even, let's extend this one more time, and then 16, right? Those, when we put these numbers in for x, are going to get us nice whole answers, right? They're perfect squares, and then we can just solve it even without a calculator. So if I put 0 in for x, really what I'm doing here is I'm taking the square root of 0 plus 3. So the square root of 0 is 0. 0 plus 3 is 3. And then you go and put 1 underneath there. Square root of 1 plus 3. Take the square root of 1 first. Square root of 1 is 1. 1 plus 3 is 4. And you're going to see a pattern happening here because we went up by these perfect squares. If I take the square root of 4 plus 3, that's 2. 2 plus 3 is 5. And you see the pattern here, it's going up by 1s. I'd always double check, put it in, just to make sure you went up by the right numbers. But if you took the square root of 9, that's 3. 3 plus 3 is 6. Square root of 16 is 4. 4 plus 3 is 7. And now we have a bunch of values that we can plot, these ordered pairs. 0, 3, 1, 4, 4, 5, 9, 6, 16, 7. I don't know if we can fit all these on here, but let's check. So 0, 3 is right here. 1, 4. 4, 5, 9, 6, and then 16 off, so we can't really plot that last one. But, and you see it does take that shape. It starts to taper off a little bit there. And when you compare, right, we knew that this parent function came out of the origin, so that +3 on the outside, all it did was shift it 3 units up. So the comparison is it shifted 3 units up. And that could be an answer for that. So if we also wanted to get the range, because it also asked for the range, right? So here's the domain. We got the domain. If it asks for the range, we look and we say, okay, it's going to be my y values. And in this case, it's going to be every y value that's greater than or equal to 3, right? So it's going to include everything above that. Nothing will go below that point right here. So it's going to be y is greater than or equal to 3, And that would be my domain and my range there. So that's graphing. We can do another example here at example 3, and it's the only difference here is that instead of like this +3 on the outside of the radical symbol, the -2 there is on the inside. So we'll see how that changes. And I think some of us can guess, right? This is gonna look a lot like those quadratic functions. So there's shifting going on when we put things within parentheses or on the outside of parentheses, or even like those exponential functions as well. So let's graph it. So the first thing that I would do is make a table. And I have my x values, my y values, and let's just make enough for 4 spots here. So the number that we want to start at is I get my domain. And I say, okay, underneath is, so let's just do this as my domain down here, make it look a little bit better, is x minus 2, and I know that that has to be greater than or equal to 0. I add 2 to each side, so I know my domain is x is greater than +2. That's the number I start at. Now, I'm not going to go to 1 next here. I'm not going to go to 4, 9, or 16. I'm not going to go to those perfect squares. What I need to do is I need to make a number that when I put in to this, when you subtract 2 from it, it becomes a perfect square. So I know that 3, if I put 3 in for x, 3 minus 2 is 1, I can take the square root of 1. The next number that I could put in if I want to get another perfect square is that 4, I could put 6 in, right? If I put 6 in, I get 6 minus 2, square root of 6 minus 2 is square root of 4, which is 2. And then let's say I want to get 9 next, I could put in 11, right? If I put in 11 here, 11 minus 2, and you can use any x values you want, this just makes it easier to plot. So then I evaluate it, put 2 in for here. 2 minus 2 is 0, square root of 0, 0. Put 3 in, 3 minus 2 is 1, square root of 1, 1. Put 6 in, 6 minus 2, 4, square root of 4, 2. And again, you see the same pattern happening here if you put in the right numbers here. 11 minus 2 is 9, square root of 9 is 3. And now we have 4 order pairs that we could plot. 2, 0, right there, 3, 1, 6, 2, and we can't fit 11, 3 on here, but we still see that curve happening. And now you see the difference here, right? Instead of that one up above, it shifted 3 up. Since this one was underneath, this one actually shifted 2 units right. So you see what's happening there. And again, these functions relate back even to quadratic functions. I still have to get my range. My range now it's now at 0 right here. So it's going to be all my y values that are greater than or equal to 0. So greater than or equal to 0. And that would be my range. And then I have answered all questions. So that's a little bit of graphing there. We're going to go on to the next page and just practice it a little bit. There is one on your own. So again, I would encourage you to stop right here just to try this on your own, see if you could graph this and then check back with mine. So I'm going to make a table of values. I know my domain, since only x is underneath, is going to be x, all my x values that are greater than or equal to 0, because x is the only number underneath. I know that I can then put in 0 here, because 0 would create that square root of 0, which is 0. And then 1, since it's only x, and then I can do the perfect squares, 4, 9. And I evaluate it. Put in 0, square root of 0 is 0, 0 minus 4 is a negative 4. 1, square root of 1, 1 minus 4 is negative 3. Put in 4, square root of 4 is 2, 2 minus 4 is negative 2, and we see this pattern, right? It's going up by 1s. Put in 9, it's going to be 3 minus 4, which is negative 1. And then I'd have these, and this minus 4, it's going to shift it down, right? When it's on the outside, it's going up or down. So it's going to be down here at negative 4, 1, negative 3, 4, negative 2, and then 9, negative 1. And you see that square root function shape take place. And then I would just have to also get my range and compare. So the range is now all the way down here at negative 4. So it's going to be all my y values that are greater than or equal to -4. And then again, we talked about this, it shifted 4 units down. That's the comparison. So it shifted 4 units down. All right, so that was our on your own. Now this last one, it really wants us to use a graphing calculator to figure this out. So it says, here it is right here. The velocity y in meters per second of a tsunami can be modeled by this function y equals the square root of 9.8x, where x is the water depth in meters. They say use a graphing calculator to graph the function. At what depth does the velocity of tsunami exceed 200 meters, right? So they want to know depth, and depth is x. So they're really looking for our x value. So what does our x value equal when our y value equals 200? So we could use a graphing calculator for this. We could also look into using some math here. So or some algebra. So let's look into this. So let's take our y value and let's substitute it in for y, and then keep this at 9.8x. So we can solve this. And when you do this, the first thing that you would need to do is you would need to get rid of that square root symbol, because we want to try to get x by itself. So to get rid of a square root symbol, you do the opposite, which is squaring it. So square each side. If you square 200, 200 squared is going to be 40,000. And this will just be 9.8x now. And now you can take that 40,000, and to get rid of that 9.8, you divide by 9.8, and you get about, I'm just going to round here, so I'm going to say about, I'm going to put that squiggly there, it's about 4,081.6, right? And we could use a graphing calculator to get this answer. Otherwise, we can just do the math here by hand. All right, so it'd be, the depth would be about 4,081.6 meters, where the tsunami exceeds that 200 meters per second. So there's the first lesson of this chapter. If you have any questions, please email me, and I will get back to you as soon as I can.